So when last you saw this machine, it had a bit of a problem. So with all of that said and done, it was time for something different for this machine. I obviously needed to replace it, so why don't I go ahead and do an upgrade? With that came two options. I had two of my good friends reach out to me. First of all was Andrew Media Man 3D Soderbergh, the creator of the Hero Me cooling system. That was Gen 3 that you just saw, and I've been running it for years with fantastic success. It's one of the reasons I haven't upgraded it. It works so good, why replace it? But he let me know that the Hero Me Gen 7 was out, like 4 generations of improvement was out, and that it was time for me to do an upgrade, and he would love to help me out with that process. About that same time though, Giles, who is the creator of this ExoSlide system here, he reached out to me and said, I have a brand new extruder I'm about to come out with, the ExoSlide Extruder, and I think that would be a fantastic upgrade over what you've been running. So I wanted to tell you about that because I wanted to say thank you to Andrew for reaching out to me. We're going to come back to Andrew's solution later, probably on a different machine, maybe on this machine. We'll see what we can do. But I really decided to take Giles up on his new ExoSlide Extruder. It's a direct drive extruder system, which actually did fill me with a little bit of trepidation because in the past, my luck with direct drives hasn't been all that great. The traditional Bowden setup on this printer has just been fantastic. With that in mind, I'm like, well, we'll give it a shot. Mainly because I looked at it and was like, this really fits in nice with the ExoSlide system. After all, he designed it to mount directly to the ExoSlides. Let's see if this one is going to be the direct drive extruder that first wins my heart. So here's the ExoSlide all mounted up to the machine. We're going to get back to the installation in just a minute, but let's talk about the impressive specs that led me to go with this extruder. So first of all, it is a lightweight solution at only 208 grams. With the motor, with the fan, this is one of the lightest solutions on the market. It is an all aluminum body, it has stainless steel drive gears, and a titanium heat break to make sure that we have really good heat separation between the heating block and the main body of the extruder. There's also a stainless steel inlet that will be used to get our filament down into the extrusion path. Now, one of the reasons I chose this kit for my solution was because it comes with everything you need to get it installed. Now, this does come in 2 pieces. First of all is the ExoSlide Extruder kit, which comes with the extruder and the NEMA 14 motor from LDO Motors. It's got the stainless steel inlet, it's got the titanium heat break, it's got the E3D Revo adapter. We'll talk about that in just a minute. It comes with the 3010 fan, and it comes with the stepper extension cable that you'll need to get everything installed easily on your system. It also comes with the screws and adapters and fan connectors and everything you'll need to get going. Now, if you want to use your existing heat block and heater cartridge and thermistor, that will be the only part of the kit that you'll need to purchase. Now, if you want to upgrade to ExoSlide's newest heat block, say you just want to replace everything, kind of start over fresh, start over with some new components, ExoSlide also sells the heat block kit, which comes with the heat block, comes with the fully enclosed thermistor that makes mounting easier and safer. It also includes a new 40-watt heater cartridge. Again, that part is separate. You can decide whether to use the one you have or whether to buy a new one. Now, for this review, I'm going to be using both parts of the new kit, both the ExoSlide Extruder as well as the new heat block kit. Now, as I mentioned just a minute ago, not only do you have the option of using their heat block or the heat block that you already have, but you also can go with a Revo adapter that does come with it. So if you wanted to go with the new Revo kit from E3D, but you really like this extruder, there is that option. So if you want to go with that solution, you can just buy the heat block from E3D as well as the nozzles, and you will then be able to use your new ExoSlide extruder with the E3D nozzle system Now let's talk about the installation process of the ExoSlide extruder. Now as you can see here, there are two 3D printed components that you're going to need to print out before we ever get started. First of all is your fan mount here. Now your fan mount has two options. First of all, there is the stock fan mount. If you like the fan that it comes with, you don't see any reason to upgrade, you can try that one first. There's a fan mount for that small integrated fan that comes with your printer. Now, if you want to upgrade, this is a perfect time to do it, and you can go and print the 5015 mount, which is what I've done right here. This is a 5015 fan going straight through this duct. Now, one thing I truly love about their duct system is that right here, it is a dual-sided cooling solution with a single fan, and I will tell you just ahead of time that this thing has excellent performance and that I'm really getting a ton of airflow with this cooling duct. Now obviously you're also going to need a BL Touch adapter for this system. Now one thing I want to show you here. This is the backside of my ExoSlide system with everything installed. And one thing you'll notice, ExoSlide already has all of these mounting holes already integrated into the system. Now, what's beautiful about this is that all of these add-ons, things like your BL Touch add-on, your cooling fan add-on, these can all use the integrated screw-on system and not have to attach directly to the extruder. This takes the load off the extruder, takes any extra motion like, momentum and everything that you're going to be adding to the extruder and puts it back into the carriage. This is a really nice solution. As you can see, this one's mounted here, this one's mounted here, and it's super easy to mount because now we're 2 screws on each of these. That's all we need here, and it's just a really nice attachment system. And obviously we still have more screws here on the back. If you want to add any sort of cable management, which I may do in the future, I can add all of that up here. Now the mounting process for the extruder itself could not be easier. There are literally 2 screws on the back of this that go directly back into that ExoSlide like I just showed you, and that is all you have to do to get this mounted onto your ExoSlide system. So if you're already an ExoSlide user, this will be super easy. Now, if you are not an ExoSlide user and you have a standard mounting plate, you'll need to design and print a mounting adapter, but that shouldn't be very difficult. A couple of screws to the mounting plate, a couple of screws to this. Again, short print and you're done. Now with any upgrade like this, the electrical installation may be the most difficult part of the entire installation. Now, if you are choosing to use your existing heat block, your existing wiring, this could be the easiest installation you've ever done, because after you've installed this, the only thing you'll need to do is put your heating block on here, one and done. But otherwise, you will need to go in and attach all of the new electrical connections for this system. As you can see, you'll have a new fan header with a new attachment here. Now, I used my own. He does provide one with the kit though. And if you use this one, you will of course have to solder everything up here, heat shrink it, yada yada. Again, he includes everything you need with this system. If you've got your own stuff, you may want to use it. Otherwise, use the stuff he's provided. If you want to use these excellent solder seal connectors for all of your electrical connections, you can use those. You can use the wiring connectors that it comes with, or you can just solder these by hand as you normally would and put heat shrink around them, which is ultimately what I ended up having to do on my thermistor wiring right here. Not a whole lot to do here. There's no changes on the BL Touch. If you're using your existing heat block and all the existing components, then you won't need to do all of your wiring connections over again. I redid mine. Obviously, this wiring harness here still comes this way. Again, I separated out my BL Touch, which goes this way. And then the only thing you'll have to worry about is how you're going to get your filament to your hot end. Now, this is a pretty easy solution to the problem. All I did was remove my existing extruder hardware. I left the backing plate on here though, put some nuts on the back, and then I was able to use all this existing hardware. It let me keep my filament runout detection. It let me keep the Bowden tube, which ran to the hot end, and then I didn't have to change anything else out. This was the easiest solution by far. It doesn't look bad. My BL Touch is now running along this wire here, and the motor wire is actually also running right here. I ran that around this way, and then it comes with the motor extension adapter, which goes here, again, runs up here. I can then sleeve all of this in the future if I want to clean it up. I left it undone for this video so that you can see what I've done here. One thing I wanted to mention before we left this area was that this kit does come with some heatsink compound that you need to install in various locations. All of that is included in the instructions, and you need to follow that carefully. That heatsink compound will make sure that thermally this is operating the way it's supposed to. It has a fantastic little brush that it comes with to brush it on all of the necessary areas. It's very, very easy to do. It will make sure that thermally this is acting exactly like you want it to. Now let's turn to the firmware, because there are 3 different settings that you are going to need to change with this new extruder. Now, if you're using an aftermarket system like I am here with the Big Tree Tech system, this is going to be really easy. All of these are accessible via the menuing system in your stock Marlin configuration. So if you need to get to the advanced settings and you need to change your steps per millimeter, you can come right here, and as you can see, I've changed mine, just like it says in the instructions, to 478.4 steps per millimeter on the E-axis. Now, from there, we also are going to need to change our PID settings based upon the new PID tuning that you're going to need for this extruder. Now, there are settings that come with the instructions. You can use those, or you can auto PID tune this yourself. That's your call. It comes with some reference settings, or you can use your own. And then finally, the last setting that we're going to need are the drive current on your TMC drivers. So for this E-stepper that you've got that will come with your extruder, it uses a slightly lower current than I was using previously. So my new setting, I've got 600. That 600 milliamps will be plenty for this extruder. If you go much higher than that, you're going to run more heat into that extruder than you need to. I've had 0 problems running at the 600, which is what was recommended by ExoSlide. Now, if you don't have one of these nice menuing systems, you can still do all of this via your USB connection on the side of your printer. Hook it up to your computer, do it over the console. If you don't know how to do it that way, you can get just and modify a G-code file, run that on the machine. It will then set those settings. Again, a lot of that is covered in the instructions that come with the extruder. So many different ways to go through these new settings, but none of them that should require you to recompile your firmware if that's something that you're worried about. So let's talk about the last part of this installation, and that is the nozzle. Now, this kit does come with a 0.4 millimeter brass J-head style nozzle, and I'm sure that works fine. In fact, I did do one test print with it, went absolutely fantastic. But on a large machine like this, I knew I did want to go with a 0.6 millimeter nozzle, and I wanted to go ahead and put the one on here that was going to last and would be the one that I just wouldn't have to mess with. I have been hooked on my absolutely favorite nozzle, which is the Apollo nozzle from a company called Performance 3D. Now, why did I go with this one? Now, as far as I know, the Apollo nozzle from Performance 3D is the only 75 grade aluminum nozzle on the market. And with that comes the absolute best heat transfer, up to 60% more than brass even, and some amazing wear rating on this nozzle. In fact, I've never worn one down. Now, I don't print abrasive filaments all the time, but I've put glow-in-the-dark filament through it. I've put a ton of carbon fiber filament through it. Never worn one down. It is absolutely the next best thing to a high-wear tool steel style nozzle, but with the heat transfer that beats brass. This isn't a nozzle review video, so I don't need to talk any more about it, but I did want to talk about this. Having a good nozzle as part of your installation is really important. This is my recommendation if you're doing a new installation. And if you do want to use Performance 3D, I'm going to have a code up here on the screen. There's going to be a code in the description that'll save you a little bit of money buying directly from them. That's a thank you from them to my viewers. Go check out Performance 3D. Let's get back to this review. So everything I have here on the table represents some part of me running test prints on this machine to get everything dialed in properly. Now, I always start with something very simple when I start with a new part of a printer, and that's just these little 20 millimeter calibration cubes. And they're great. They show you, is it printing properly? Is there anything majorly wrong with it? Just start with those. See if you're still getting 20 millimeters out of each direction so that you know, am I basically printing what I thought I should be printing? Now, once you get those going and you're happy with them, then it's time to start looking for your flow and your steps per millimeter calibration, which I'm going to link you to in the description. It's either going to be one of my videos once I ever get one posted, or it's going to be linked to Matt's Hub, which is a fantastic website that has the extruder and flow calibration I have been using for years. Now once you have that dialed in, then I go immediately to find out what is my retraction settings going to be for this particular extrusion. Obviously, it comes with recommendations. The recommendations for any extruder is a fantastic place to start. But anytime you're doing it, your machine may be slightly different than the one that they're using for testing. So, ran through all of these. These are using the Auto Towers extension that you can find in Cura. What I have here is I start with figuring out the distance. So I ended up, while I think their recommendation, if I'm not mistaken, was 0.8 millimeters retraction, I ended up at a 1 millimeter retraction. Not much difference there. And then once I had the distance retraction dialed in, I went to the speed of the retraction. I ended up here with a 60 millimeter per second retractions. So now that's 1 millimeter at 60 millimeters per second retraction on my machine with this nozzle. If you change the nozzle, if you change the type of filament you're running, all of these settings could change for your machine. So be sure to rerun this if you're not getting the results you want. Now from here, I generally go to look at kind of what speed can I run at. So now again, that Auto Towers extension can generate these as well. These are kind of looking at, are you seeing ringing? Are you seeing any issues with those print settings in terms of speed? Using this, I found I really wasn't seeing much ringing with this extruder and with that particular nozzle size. So that let me know I'm pretty open to what speed I want to run at. So I chose a kind of fast, a kind of conservative 80 millimeter per second print speed for all of the prints you see here on the table. They're 80 millimeter print speed with the slower parts of the print at 40 millimeters per second. Now the last thing I needed to do was kind of dial in my cooling, which is where all of these come in. This is a model which I will link to in the description that is a really useful way for looking at all 4 ways that you are going to need to cool a model. So the way I usually print this is I usually print it with one of the corners forward so that I have a front, a side, and a back for each of the directions. And here I can take a look at the underside of these to kind of figure out where my cooling breaks down. And a really good cooling on a printer will get you to about 65 or 70 degree overhang without failing you. So for this configuration, they did recommend a 50% fan speed, and you should get really good cooling. Now, that's what I started with. I did print some of these at a 50% fan speed, and then I printed some of them at 100% fan speed. So while I did think that the 50% did all right, it did end up capping out about 50 to 60 degree overhang, which just isn't that great, at least not in my book. So I went up to the 100%, found out 100% way better. Love the 100% cooling. Looks absolutely fantastic, all up until where we're nearly at the 80 degree overhang level, which you never expect really anything to look that great. Now let's go into the next part of this test print journey, which is taking up the majority of the table here. And that is what I primarily print with this printer, and that is cosplay, helmets, armor, things like that. So what I have here, this is a armored Deadpool mask from Yosh Studios. I'll give you a link in the description on where to find his Patreon. I went through this journey of getting this dialed in perfectly. It's got some good hard edges. It has a lot of smooth surfaces. If your printer can print something like this well, then you should actually have pretty much good results on everything else. Let me go and start with the 0.4 millimeter version of this. So the 0.4 millimeter version of this turned out absolutely, dare I say, just about perfect. The layer lines look clean. The consistency across all of the layers look really good. And this is a 0.4 millimeter with the brass nozzle, 80/40 speeds on here, and it really turned out quite nice. Now, when I switched over to my 0.6 millimeter nozzle, I actually ended up with a model that looked almost identical to the 0.4. Again, very consistent layers, great movement. The only problems I really ran into though, on this one you can see it right here, it is the starts and stops of the nozzle. It is the extrusion parts where the nozzle has retracted and then is starting over again. So as you'll see right here, you get some areas that just don't start correctly, that it doesn't prime the nozzle correctly. Now this is as much a problem with direct drives with larger nozzles, and I really don't see this much with Bowden installations. For some reason, that the way that they retract, you end up with less of it leaving the nozzle and having to be re-primed. So again, I had to play with my prime settings, I had to play with my retraction speed settings to really get these cleaned up. And as you see here, this set of helmets really represents me testing it over and over and over. And again, I ended up finally getting it fixed. You'll see it right here where we definitely got that cleaned up. And again, I'm still tweaking this, always tweaking the settings, making them better. So if it pops up again, if I'm still seeing just a little bit of problems, I can play with those prime settings to get that nozzle primed again. Again, if you're using 0.4 millimeter nozzle with this, you're not going to really see this problem, but with the 0.6, 0.8, you're going to see these kind of problems quite often with direct drive, at least I have. So from there, I went ahead, wanted to print another highly detailed model. This is a beautiful model from Clock Spring 3D. This is, I'll put up here on the screen right here what it's actually called, but it's their pirate chest. You can see it's got the Kraken coming up here, holding on to the pirate chest. This is a print in place model. Let me show you why. See that? The lid, it printed just like this. So it has to have very good tolerance, but as you can see, this thing is absolutely gorgeous. The only problem I saw on this entire print, no problems on all of the other sides, but on this side I saw a little bit more of that start-stop problem right here. And with that, I am still playing a little bit with those prime settings to get that cleaned up across the entire print. But I did want to show you that here. That's something that even when you think you got it dialed in, you might have to do a little bit more testing. Now keep in mind, I'm going to provide my settings in the description. I'm going to give you a Cura profile that you can use with this machine. I'll also outline some of the settings just line by line so that you can type them in manually. Or if you're using a different slicer, you'll be able to just type those in to your slicer. Again, I was really impressed with this model. Obviously, Clock Spring knocked it freaking out of the park with this model. It's functional. You can put magnets in here. I just love this. One of my favorites that I've printed recently. Thanks Clock Spring for that one. Again, if you're interested in Clock Spring 3D, link to the Patreon in the description. Finally, wouldn't be direct drive if I didn't also show you printing of some flexible filaments to make sure that this is also a universal in terms of like, let's print some really good flexible things. So got some SaneSmart TPU here. As you can see, this stuff is super flexy and it printed absolutely gorgeous as if it was PLA, just like the rest of my models, and it looks fantastic. The underside's a little rough, but that's just due to the way TPU prints, the fact that I didn't run too high a cooling on it because I wanted to make sure I got very good layer adhesion, and so this will need a little bit of cleanup. But what this is a neck seal. As you can see right here, working on a neck seal for a costume, and this is going to be my go-to extruder for printing this model because it printed it great and very, very clean. Like I said, I love to see the extrusions like this looking so good. So that's what I've got here on the table. All right, let's wrap this up. Let me give you my overall impressions of this extruder. So what are my overall impressions of the entire process, the product, ExoSlide as a whole? So let's start off with the ExoSlide system because I think that is a pretty important part of the entire thought process and which extruder you're going to choose. Now, first of all, I have been using the ExoSlide system for years on this machine. One of my favorite parts about using the ExoSlide system is that it's a good quality motion system that runs along your rails, is a lot easier to install than using like a rail system because you have less to print, less to put together. It's kind of out of the box, you put it together, but I've been very happy with it. Because of that, I thought that using their extruder system was the way to go on this. It made installation a lot easier. I like the way that you attach all of the cooling and all of the peripherals to the ExoSlide system, makes that part easier, and I really like where it puts the center of gravity and everything for your entire motion/extrusion system. Now, the actual prints coming off of this thing, couldn't be happier. I really think that this takes the machine somewhere that I'm happy to take it, and that's to a direct drive extruder. It increases the capabilities of what I can print, and I really like the how light they've made this, so I worry a lot less about what it will do to the overall performance of the machine, moving from a Bowden system, which I've been very happy with my Bowden setup for years now. All in all, I'm happy with this upgrade. It did require a fair amount of work to get everything installed because there's electrical work here to be done, at least moving to all of their upgraded components. And so it's something that's fairly involved, but not out of the grasp of the majority of my viewers. And again, if you don't like to do the electrical stuff, if you're worried about the capabilities there, keep your existing hot in, keep all your fans and everything, just install the new extruder on your ExoSlide motion system here, you're good to go. Now, if you're not using an ExoSlide motion system, let's talk, because there will have to be a mounting plate made in order to adapt the ExoSlide installation, ExoSlide extruder installation to your stock mounting plate, whatever printer you may be using. And because of that, there's an extra step there. Keep in mind, almost every solution is going to require those mounting plate adapters. They can't adapt to everything. Everything's going to require some sort of adapter. So that's not really a knock here for ExoSlide. Everything's going to be adapted in some way. That's going to apply to pretty much any aftermarket extruder that you purchase. So that's it. Will I recommend this? Absolutely, particularly for ExoSlide owners. But obviously, as I've shown you here, the performance of the extruder doesn't rely on the ExoSlide system. It performs well irregardless of what printer you're going to put this on. Just think that this is particularly well adapted if you're already running the system. So if you are looking for a motion system upgrade, go with the ExoSlide. All the links are going to be in the description on where you can find ExoSlide, where you can find the extruder, all of that down in the description. So as we close up here, I hear you ask yourself, how can I help support this channel? I really enjoyed this video. Well, thank you for asking. All these people over here at one point asked the same question, and I gave them the answer of, hey guys, I've got a Patreon, and you can go over there. You can choose to contribute to this channel monthly, and it really helps me produce videos like this and do projects like, if you haven't heard, I'm doing a little something with Iron Man over here, and it helps with those projects as well. So go check out the link to my Patreon down in the description. It'll also be at the end of this video if you want to support me month to month. I also may be enabling channel subscriptions very soon on the channel, so if I've done that, you'll be able to find the link to join the channel down below as well. Thank you to Giles over at ExoSlide for providing this extruder for me to take a look at. You were fantastic getting me back up and running. And again, I also want to send a shout out to Andrew Soderberg for also offering help with a new cooling solution for this printer. I'm sure you'll be hearing from him very soon in the future. So thank you, Andrew, again for reaching out to me. If you're interested in the Hero Me cooling system, which I am still running on my regular Ender 5, go check out a link to the Hero Me solution in the description. I think that is about every link I can give you for this video. So again, if you're new here, I'm Chris. This has been Kersey Fabrications, and I will see you next time.